Hey guys, how are you doing? This is JSer, who is not good at algorithms. In this video, I'm going to take a look at number 785 of LeetCode is graph bipartite. We're given an undirected graph, return true if and only if it is bipartite. Recall that a graph is bipartite if we can split its set of nodes into two independent subsets A and B, such that every edge in the graph has one node in A and another node in B. So the graph is given in the following form. Graph I is a list of index j which the edge between nodes and j exists. Like this, it means at the index 0 there will be an edge between 0, 1 and 0, 3. For here, it means there will be an edge between 0, 1 and 2, 1, right? So this, and for third one is 1, 3, yeah. And for the last node, it was 0, 2. Okay. There are no self edges, means a circle to itself, dot, right? And the parallel edges means there will be no double edges. And so if for the example like this, we're sure that we could set 0, 2 to a group and 1, 3 to another group, right? So for each edge, actually, it will be just bipartite. So for this edge, it's from this set and this set, this set, this set. And for if the case is like 0, 1, 2, 3, of course, for these three edges, we must set 1, 2, 3 to one edge, right? Because they are all connected to 0. And but we cannot put 1, 2 together and 2, 3 together, or 2, 3 together. So it's impossible. Return false. Well, from this example, I think we could find that for two set, if we set this 0 first node to one set, we can already set the 1 and 3 to another set, right? Because there are edges to them. And if this one is set to another set, and the node connected to it could be determined to a set, right? So actually, we could walk through all the graph and determine the which set it is in, and try to determine that, right? Like say, at first for the first node, there is nothing node set yet. We could mark it as the first set, and because this 1, 3 is connected to it, we set 1, 3 to another set, and then we can do it like recursive way and mark them all, right? Suppose there are a case that there might be standalone groups of nodes. Like for this 2, it connects to 4, but there will be no connection between 1 and 2. If that's the case, we cannot mark 2 and 4, right? Yeah, but that's actually an independent problem. If we can separate these groups to bipartite two sets, and we can also set the 2, 4 to bipartite two sets, and then in total they could be merged into two sets, right? So yeah, so the problem so we can do it like this. We will loop through all the indexes, like nodes, and try to mark each node with a set marker. Like we mark it 1, or okay, we mark it 1 and 2, and then we will loop through all the graph and mark them. Well, in this we could do it just in a recursive way, right? Okay, so if you work recursion, it's gonna be in DFS. And then once we found that we cannot mark two nodes, like for this case, for 0, we mark this one to 1, and then mark this to 2, and this to 2, and this to 2, right? And then we need to go to this one. Oh, because if you use recursion, it would be like DFS. So this is 1, and then this is 2, and then this is 1, right? Go back. It's already set. We skip and go to here. It's and so 1, 2, this 1, so 0 should be 2, but it's already set to 1. So yeah, there's a problem. So we can return false, right? Yeah, cool. So this is our first solution. We use a recursion to mark all the nodes. So we create a walk method, the node, which is the the node, and the marker mark. We define the mark with, because two sets, we can set it to like 0 as unset, and 1 set A, 2 set B. Okay. When we walk a node, we set the mark. We set the node to a mark. So for the node is actually a series of numbers. We could create a marks array. Filled with 0, which means they are unset. Okay, so we walk. Sure. So when we walk, we get a node and a mark. We first determine if the node is set or not, right? So if node marks node is already set, okay, wait a minute. If it is already set, then we should skip it, right? So if it is not a 0, means it is already traversed. If it is already traversed, then if it is not equal to mark, it is not equal to what it should to be, like the 0 here. It first marked as 1, and then from these two, from these two perspective, this 0 should be 1, 0, 1, 2, 1, 2, 1. This should be 2. So we have a problem here. So we return a false, right? Okay. If it is, we return true, right? If it is not set yet, what do we do? We set it, right? Node equals mark, and then we will recursively mark the connected next nodes adjacent. Am I spelling right? Note. It will be for let node that next of graph node. The next mark would be mark equals 1, should be 2. Yeah, we toggle the mark. Okay, so we walk there, right? But if we found something irregular, we could just break. Okay, so if walk next node, next mark, if it is false, we should break. No, we should just return false. And this will be already, we could just return false, yeah. Okay, when this round, yeah, so if all the children, like for 0, all the next node, 1, 2, 3, are all valid like this, there's no problem, right? So for this case, we return true. This true could be actually put at the bottom, right? Return true. And so we will, at last, as we said, there might be disjoint groups of nodes. we for net node we walk, because this for each traverse, it should be, if it is connected, this should be done in the previous check. And if we are setting the new mark, it must be disjoint. It doesn't matter we set it to 0, 1 or 2. If we found they are not satisfied in our, they're not valid, we return false. And at last, we return true. So this is our whole solution. Let's try to review our code once more before we submit. Okay, take this as an example. First, we go to 0 and then mark it as 1, right? And then because it's 0 and we mark this as 1, and the next should be 2, and for the off, yeah, we have an off missing. We walk to 1 with 2, right? Okay, so we set it to 2 and walk to 0 back for 1. If you walk back, it should be 1. And it is 1. So we go to next one, which is 2. For 2, 1 to 1. It should be 1. It's not set. We set it to 1. And then it will go to 1 again. It should be 2, but it's actually 2. So we go to 0. We first go to 0. 1 to 1. So 0 should be 2, but it's not. So we return false. When these 2 return false, it means the 1 return false, right? And 1 return false, 0 return false. Yeah, so they are all return false. So for the 0, it return false and then return false. So I think this should work. It's not. Sad. We set it with 0. What's the problem? Okay. Okay. Let me check. First, we loop through all the nodes and walk them with 1. Yeah. I made a mistake. If the nodes is already set, this doesn't matter. So actually, we need to check if walks marks I equals 0. And if marks 0, we walk them, right? So if we walk them, I with 1, we return false. This should work. Cool. Let's submit. Yeah, we accepted. That's just a weird little slow. Let's try to analyze our time and space complexity. For time, actually, each edge will be traversed for once, right? So each edge actually will be traversed twice. So for the n would be the edge length, the n set to count of edges. We are actually walking through the edges, like 0, 1, 1, 0, 1, 2, 2, 1, like something like this. So it actually should be linear time. Space. We use node set. The node equals to m to the node name. This is the extra space, right? And there will be a call stack of this recursion. While each is maximum, the like 0, 1, it's like maximum is the m, right? So space is m plus m is still m. So yeah, so this is our solution of recursion. But for each time when we are doing recursion of the tree, we could try to rewrite them in iteration. Let's try to do that. But first, for our recursion, it's actually DFS, right? So let's try DFS with a stack. In your case, if you DFS, a stack. If it's a BFS, it's a queue. What's this gonna be for a stack? Well, I think the idea is the same. First, we initialize a marks array to keep track of the marks, and then what we do, of course, we loop through all the nodes, right, to see if it is marked or not. If it is not marked yet, we will try to start a DFS on this node, right? Start a DFS start from this node. Well, a stack. We set I into it. This is the node, and don't forget we marks I with 1. And then we will push the children into the stack, right? So that will be every time we pop an element from the stack and then push their children in. So that's gonna be DFS. Okay, so while stack length, while stack has an element, const top equals stack pop. We pop the element that for the 0 here, we get 0, and then we'll put their children in it. So for let, not children, but next node. This top. And then what? We need to mark them, right? So the mark here would be, well, the mark should be mark top, right? So actually, next mark should be marks top equals 1, 2, 1. And then we need to set the next one to the marks. But there's a problem. If it is already set and it isn't to, if it is already set and if it is not the next mark, then we should be returned, right? There's an error there. So if a marks next node, if it's unset, that means it is not traversed yet. Not traversed yet. We marks next node equals next mark, and we push it in next node. Right? Yeah. For the other case, if it is the next mark, it's okay. But if it's not, like marks next node is not equal to next mark, we could just return right away. We return false. Yeah, and so this is actually the DFS search, DFS approach, and finally we return true. Let's try to review our code once more before we submit our solution. Suppose like this for 0. Our first marks 0 is 0, and then we set it to 1, and then we push the 0 into the stack and pop it out every time. So we pop 0 out. The next mark should be 2. Okay, and the next node will be 1, 2, 3, and all of them are 0, so we mark them with 1, 2, 2, 2. Okay, so 2, we mark them and push them in. And now we pop it, and it would be 3, right? So the 3, we get 3. We get 3 out. And then next mark should be 1, 2, it should be 1. And we get the next node, which is 0, 2. The first one is 0, so it's not 0, and it's actually is 1, so we ignore it. And go to 2. 2 is not 0, but it's already 0, 1, 2. 2, but it's not 1, so we return false. So yeah, this also should work, right? Cool. Let's submit. So it's working. The idea is the same as the recursion solution. Let's analyze the time. The time actually is the same. So we'll take the count of the edge and the space. Here, OM is inevitable. But we avoided the call stack, you see. No. So we actually use a stack here. This will be maximum. What is it? If we push 0 in and then 1, 2, 3 in, and then we pop 3 and then push the next element, right? So the worst case is actually all of them are into this temporary stack. So actually, its worst case is still OM. Cool. And what about BFS? For our problem here, actually, DFS doesn't matter, I think, because the only thing we care is that for the disjoint nodes group case, right? And actually, even BFS, it will finally reach to the last leaf node for a tree. So BFS still works in this case. Still works. Let's try to rewrite our code. For a queue, for BFS, we use a queue, right? So the outer for loop is the same. We mark the first one to 1 and use a queue. We use a queue and push the I in. Yeah, and then if q is bigger than 0, now we were handling like a layer by layer. Okay, so when we are getting the the next head of the layer 1, 2, 3. When we get it, the mark is already there. So we could set next layer to, yeah, okay. We don't need to set a, we don't need to actually set a ending flag. We could just get the head and push push the children to the bottom, to the rear. Okay, we set the head equals that shift. So next mark should be this, right? And for next node of graph head, and if next is 0, it means it's not set yet. We set it to the next mark, and q we push to the next node. If not, it's false. Yeah, so actually this should also work. No, stack is not defined. God, I use a queue. Sorry. Cool. Yeah. So actually, it doesn't change that much. The only thing is the order, right? Before we push all the lists, like push 0 in and push 1, 2, 3 in, and handle 3 and push the 3's children in. So the first one closest to 0 is handled last. But if we are doing in BFS way, you see the first one we handle 1, 2, 3, and then we will handle 1 and then 2 and 3, right? We push 1 to 3 and then we handle 1 to 3. So it will gonna be layer by layer. So cool. So BFS still works. Let's take a look at its time space complexity. For time, I think it's the same. The count of edges, space. This extra m is inevitable, and the q actually is the maximum layer. Wow, it's for worst case. Yeah, it's still the length of the node, right? Yeah, cool. So that's all for this problem. Hope it helps. Remember, for a tree, recursion, and then try to analyze the time complexity and give the reviewer interviewer your idea. But you should not write that. I think we should write a DFS thing or BFS. It is much clearer. Except for some special case that writing into the iteration way is very tedious. For that case, I think we should give it up and say, okay, if our time will just rewrite it, but the recursion works pretty well or something like that. Okay. Yeah, for this graph, think of it like a tree and do the traversal. Hope it helps. See you next time. Bye bye.